Next, we have Dr. Matthew Vann. He's going to come up and have a few words. He's a researcher and extension specialist. He's like a lot of other people, extension, the better job you do, the more jobs they give you to do. So I don't know how he gets it all done, but we are still glad to have him on the agronomy side doing work. Matthew?
All right, well, thank you, Derek. When some folks say that, they may call me a jack of all trades, master of none. So you had a little better way to put it, at least for me. So, Hank, Veronica, Derek, board, thank y'all for having me out today. I don't know that I have missed a Tobacco Associates meeting in my career. It's always one of the latter ones we do before we start to roll into planting season. And I know that's just right around the corner. So it's one of those meetings that kind of marks the milestones throughout the year. So again, my pleasure to be here, and thank y'all for having me. The times I've been able to speak to this group, it's offered me an opportunity to talk about maybe a unique topic every time that I've not been able to really address at some of our county meetings, and are things that may not come up elsewhere. So this, again, has been a good opportunity for me to talk about something a little bit different. And what I'm going to talk about today is one of those things. I'm going to keep with that theme. Talk about planting considerations, but my major focus is going to be on starter fertilizers. And as we think about starter or pop-up fertilizers, you go back and look at our production recommendations. These are not part of our standard recommendations. These are some of the things that we get questions about every year. We have seen positive data that would suggest that there's some value to having these things included in the transplant water. And we've seen firsthand and have seen research trials where we've seen negative effects of having starter fertilizer in the setter water. So today I'm going to talk a little bit holistically about some trials that we've done in my program, and talk about maybe some of the benefits that we have seen, and again, some of the nuances of what we've been using and where we think these things may have a good fit. So again, if I go back and look at why we're doing some of this work, one, it really goes back to things that y'all have engaged with us about. You're talking about starter fertilizer, talking about the different products that are, again, offered to y'all through some of our retailers. And then really diving down into, is this something I need? Is this an absolute must-have? Or what's my risk up? Is there just too much risk with using some of these products that we don't know a lot about? So kind of going back over the last, I'm going to say maybe 10 years, really as I've kind of hit the ground running as a faculty member working in extension, this has been a topic, again, that I get asked about year in and year out. So we've done some trials. As you'll see, I'm going to show a little bit more robust data set that's more than just one or two or three or four field sites. This is going to span back for a number of years, and if my memory is correct, I've got about 8 field sites that we're going to show data from, and I'm going to show a couple of different ways to look at this data, again in a way to maybe explain some things and help you make a decision about what you might do as we start to look down the barrel of transplanting. So if we look at some of these starter fertilizers, why is there feasibility here within our tobacco systems? I think the biggest reason that we can use some of these pop-up or starter fertilizers is because we have a lot of legacy phosphorus that is serving from a residual standpoint from season to season in our traditional tobacco soils. And I go back to some older data that we've got from the agronomic division with NCDA. But there's somewhere in the ballpark of about 80 to 85% of our tobacco producing ground here in North Carolina has got enough residual phosphorus in it from years of over application of phosphorus that we don't need to apply in-season supplemental phosphorus. So we can lean on some of those legacy reserves, mine the soil a little bit, and again, that's where these pop-up fertilizers really show themselves, because we're only talking about putting out a small amount of phosphorus, and I'll get to some of that later. As we've moved to some diverse nutrient input options, we, again, 15, 16 years ago when I started, we saw a big emphasis where folks had moved away from some of the traditional homogenized, ammoniated NPK fertilizers, and they were looking at more of your prescription-based fertility programs. This allowed us to kind of take phosphorus out of those NPK blends, and we could plug in a little bit of phosphorus from a starter standpoint. So that worked pretty well. And again, looking at efficiency. We've seen situations where, we set tobacco and ideally we're in there within the next week or so side dressing for our base fertilizer application. But when the reality sets in, that's not always the case. We set tobacco, and let's say we get a big rain and we just can't get back in the field for 10 plus days. Having a little bit of starter fertilizer in that system is going to be good for the plants, because they're not going to start to go hungry before you can get the base applied. So again, something else just in terms of efficiency that works. So when we look at these systems, our overarching goal is to just reduce phosphorus application. And that's when we talk about phosphorus or starter fertilizer, phosphorus is the one that really rules the roost. And I've said to some fertilizer manufacturers that if you could make a water-soluble phosphorus-only fertilizer, that would have a really good fit in tobacco production, because I don't think we need the small amount of nitrogen or the small amount of potassium and some of the other things that may come with these products. It's really on the phosphorus and what it's bringing to the table in terms of stimulated root growth, and then what that means for promoting vegetative growth. And then finally, looking at one of these last bullet points, based on one of the last surveys we did, which is a little bit dated, surveying our county agents on this particular topic, it was estimated that about 20% of our growers here in North Carolina are using a starter fertilizer to supply all of their phosphorus needs. So we're looking at a crop in fluke-cured tobacco that needs about 12 to 15 pounds of phosphorus per season for maximum yield. We're getting about 5 from the starter fertilizer. And in 20% of these cases, that's all our growers are applying. So those statistics, in my mind, kind of ebb and flow. That number may look a little bit different today than it did 8 to 10 years ago, but the bottom line is there are growers that have an interest in maybe utilizing a starter fertilizer program as their only source of phosphorus. So again, that's some of the background that kind of justified why we wanted to look at this work a little bit more holistically. So again, why are we using a starter fertilizer? I put this together, and instead of maybe starting with the good stuff, I started with the bad stuff. So one, when we look at a starter fertilizer, I don't know that I've ever seen a unbiased, independently verified data set that shows that there is an additional boost in yield or quality when we use a starter fertilizer compared to where we don't. So we're not seeing additive value in terms of yield and quality. So that, again, is probably a negative we may think about. There's variable product cost. So that's just a simple math number. Some of these starter fertilizers cost more than others, and some are easier to apply than others. You think about a dry, water-soluble versus a liquid product. And then the risk of stunting and injury. And again, we've seen that firsthand with some products. So why would we use it? Well, we have seen a documented positive response to early season plant vigor. The downside to that is that response is not always consistent, and you'll see that a little bit later in this data set. But we often have associated the boost in just visual plant growth and just, again, vigor in totality. We've often seen that associated with cooler, damp soil conditions. So if we're going into a transplanting season where we've got wet soil and it tends to be a little bit cool, we know that small amount of phosphorus in the setter water is going to be a way to kind of help those plants push through and get through those cool conditions. And there's a couple of reasons for that. One, y'all hear me say this all the time, we got to remember that tobacco is a tropical plant. So if it's going into a cool, damp soil, that's not a real conducive condition for where that plant was, first sort of evolved from. Second, when we look at phosphorus specifically, as soil temperature declines, phosphorus uptake and movement in the soil declines as well. So if you're putting phosphorus in a band 3 or 4 inches away from the plant, it's going to have a little harder time getting to the root system versus when you put it directly in the transplant water. So again, that's an efficiency thing that can be beneficial. So again, ultimately, my take-home message from this slide is this is not an absolute necessity, which is why you don't see it as part of our standard recommendations. You can certainly grow a perfectly fine, outstanding crop of tobacco without a starter fertilizer, but if we go into situations where a grower's interested in this, or we've got environmental conditions that may prove to be beneficial to use one of these products, this is why we're doing some of the work. So what I've done is I've summarized some of our field trials from 2021 up through this past growing season. And the 2 objectives we had really within that is to predict starter fertilizer response across a wide range of growing environments. Y'all think back from 2024 to 2021, we probably had just about every different kind of growing condition that you could ask for across those different field sites. We've talked about 2024 already, but we've had cool and damp, we've had hot and dry, we've had everything in between when we look at some of the transplanting seasons that I'll cover. And then to start to break apart some of the data a little bit, in that third objective, I wanted to maybe see if there was a possibility if I could go back to this bottom point and really find something that stands out to definitively say, yes, under these conditions, I would 100% recommend you use a transplant water starter fertilizer. So again, we started to kind of dive into the data a little bit deeper on that. So you'll see two different ways of looking at this data. The first is going to be sort of the larger aggregate data set, where my goal was to say, on average in North Carolina, I could pick any growing environment out there, Sand Hills, Old Belt, Eastern, doesn't matter. If I drop a plant with starter fertilizer in that system, what is my likely outcome? So you'll see that in one particular data set. And then in the final data set, I've got everything broken out, looking at soil temperature, air temperature, rainfall, soil moisture, all those kind of things, to really see what specifically we might be able to learn. So to get through this a little bit more, you see our 3 different testing locations, and then within each location, you see the years that are represented. So again, in total, we've got 8 different growing environments that are captured in this data set. And then these are our different soil conditions. So don't get too bogged down on this, but ultimately you're seeing the different soil series, the soil types they represent, soil pH. You're also seeing, again, percent organic matter, not that that's a super important one for us to look at, and then residual phosphorus, and then the associated phosphorus index that you would see with that particular field site from our agronomic lab, and then what that means in terms of a high, very high, medium soil phosphorus index. So ultimately the take-home message here is these soil types are very representative of what you would see on most of y'all's farms. Now there's probably some exceptions in here. Again, we don't have an extremely sandy environment, and I would argue that we don't have a really, really heavy clay that may represent some of the western region of the Old Belt. But on average, this is some pretty, what I call Cadillac tobacco soils. And then more importantly, our pH is pretty much appropriate. And then residual phosphorus, we've got a pretty wide range of things that would test medium all the way up to very high. So again, a pretty good diversity in terms of growing environments. So we applied, I'll get to our treatments in just a second, but we made our starter fertilizer applications at transplanting, so they went out into transplant water. Our transplant water volume was 100 gallons per acre. And when you look at the different field sites, our transplanting dates range from the earliest planting date being April 17th to the latest being May 13th. So pretty well in line with when we would see the majority of the tobacco set in these respective areas. The only treatments we really had were at transplanting. So everything that happened after transplanting were done as sort of a best local practice. So we let the research station tobacco managers do their job. You manage this crop just like you want to. You get to pick the base fertilizer you use. You get to pick when it's applied, how it's applied, what that product is, all those kind of things. So that means that we had some different varieties, obviously different planting dates, and then certainly some different nutrient sources that were utilized. And we had anything from a traditional NPK blend like an 8824 or a 6618 as a base program, all the way to some custom blends that were liquid, some were dry, and then again some custom nutrient applications where we had a little bit more of a prescription program where we may put out K-Mag and a little bit of phosphate before transplanting in a broadcast application, and then we side dress UAN after the fact. So we've got a lot of different programs represented in this particular trial. Now in terms of data collection, there's a lot that went into that, and it pretty much focuses on what's happening in the early part of the growing season. So we've got plant dry mass, plant height, vegetative width, and foliar nutrient concentrations at 2, 4, and 6 weeks after transplanting. So we're tracking what's happening with physical and chemical growth in a sense up until about lay-by. And our historical rule of thumb is that once you get to about lay-by or just after, be at about that 6-week mark, you really start to see some of the differences in vigor kind of fade out. You know, normally, again, you can walk out, see it, and then after lay-by, it's not as obvious. But we'll show you some data that may be a little contrary to that. And then we've got some yield data that we'll show as well. So in this first, or let me show you my treatments here. So I've got 2 treatments. So this particular data set and the way we analyze this data is about as simple as I could do, thankfully. And it's pretty easy, I think, to kind of wrap your mind around what we've got. So we've got a water-only treatment that was 100 gallons of water by itself, nothing in the transplant water, no pesticides, no nothing. And then our treatment 2 would be water plus 945-15. So 945-15, I may misspeak here, but I think that was probably one of the first transplant water fertilizers that y'all as tobacco farmers had access to. That's an SQM product. It is what I would call a dry, sort of granular, water soluble product that does have to be dissolved and mixed. But we still had our 100 gallons of transplant water solution, and then we added 11 pounds of 945-15 to that solution, and that ultimately gave us the 5 pounds of P2O5 that we were trying to shoot for. And again, the 5 pounds was our target because that is what the literature says is the upper limit for what we need in the setter water. We did a couple of different trials back, I think 2020 and 2021, where we tried to push this to about 10 pounds per acre in the transplant water, and we had no additional improvement on early season growth and all those kind of things as we went from 5 to 10 pounds. So we're going to stick with the 5 pounds of P2O5. The other disclaimer I'll give is that we've evaluated other starter fertilizers from other companies and other manufacturers, but this is the one product that we have that is consistent across all the different growing environments. So we're not trying to necessarily highlight this product, and we're not picking on others. This just gave me the biggest data set to lean on for this presentation today. All right, so here's, again, more on that label. One of the reasons we've looked at this is it's been used for a long time. It's compatible with some of the other pesticides that we've got access to. So, again, seems to be pretty popular as a whole. And then as I jump into the data, you'll see some things that are of interest, but I thought this picture was pretty interesting in and of itself, and I think this is why there's a lot of interest from y'all in trying some of these products. So this is from 2023 at our Rocky Mount Research Station. This was 6 weeks after transplanting. We flew a drone over our test plots. And in the top you see that is a water by itself, and then here on the bottom that is with the starter. And I think that at least visually, I feel comfortable saying that those visuals are legitimate, as you'll see in some of the data. And I think y'all would probably agree that looking at those bottom pictures, you've got a little more consistent plant stand, minus the one plant here that's got some tomato spotted wilt virus. Everything looks to be about the same sort of dimension and have sort of the same growth rate in that bottom picture, certainly compared to the top where it seems to be a little more erratic. So again, I think that's one of the other benefits that we could be looking at from a starter fertilizer standpoint is faster growing crop, it's got more vigor early on, and if it's just more uniform, maybe that helps with some of the other things that we've had issues with over the last few years. All right, so to get into some of the data, plant dry mass, and I'll just orient you here that we've got our 2-week, 4-week, and 6-week after transplanting measurement intervals here on the x-axis. Y-axis would be our dry mass, so just how much the plants weigh after we remove them from the test plots and dry them. And then the gray bar would be without starter, so that's just water by itself. And then the blue bar is the starter fertilizer, and I've got it in blue because the product's blue, so maybe that's a little easier to remember. But if we look at all three of these measurement intervals, it didn't matter what the interval was, but where we included 945-15 in the starter solution, we had bigger plants. So we physically removed plants from these test plots, we dried them down, and we weighed the dry mass, and in every one of those situations we had a heavier plant. So that just meant there was, again, more biomass there. So that's a good thing. Even out here at 2 weeks after transplanting, the plants don't weigh a lot, they're not super big, but you're still picking up that benefit, again, to a small degree from that extra phosphorus that's in the solution. Now, interestingly, as we look at plant height over those same times, so we took plants out of the ground and we measured all these plants were measured, all these measurements came off the same plants. At 2 weeks after transplanting, we did not have a significant difference in plant height between our two treatments. But as we get to 4 and 6 weeks after transplanting, we did see slightly taller plants where we included a fertilizer in the transplant water solution. And as I look at this data, you go back one slide, the plants do weigh a little bit more, but they're not necessarily any taller. I think there's a physiological reason for why this is happening. And I think about something Bill Collins has always said, for the first 2 weeks after you set tobacco, it should look like you hit it right on the bud with a ball-peen hammer. We're looking at more more lateral growth and expansion than we are vertical growth. So I think that's really more what's playing into why there's no difference there, in spite of us seeing plants that are just heavier in a dry biomass measurement. So again, taller, moving out to 4 weeks and 6 weeks. If we look at nutrient uptake, and this is not from every field site, but I think we've got, no, we do have all 8 field sites represented here. I've got this set up a little bit different, so I've got nitrogen, phosphorus, potassium, magnesium, and sulfur here at the top, and then 2, 4, and 6 weeks after transplanting. And again, we're just comparing sort of within each interval the with and without starter. And it's only at 2 weeks after transplanting that we see a significant increase in nitrogen, phosphorus, and potassium. So I thought it was kind of interesting that even though we're not real gung-ho on the nitrogen and potassium part of these starter fertilizers, we still are picking up just a little bit more, even though we're talking about a 1 pound, 1.5 pound per acre application difference compared to a 5 and 0 pounds of P2O5. So again, we're picking that up. No difference in magnesium or sulfur. And then again, to my surprise, as we get to 4 and 6 weeks after transplanting, those differences sort of play out. So it seems like we get this early uptake, and then we start to have enough root growth that's coming on for these plants to pick up whatever phosphorus is applied, in a side dress or a base NPK application, or whatever is residually in the soil profile as legacy phosphorus. So again, just early on in that very critical early stage is where we see that benefit take place. Now, vegetative width, and this is just us measuring plants, looking at the biggest leaf on the plant, or the 2 biggest leaves, and kind of pulling them straight apart and seeing how far apart it is from leaf tip to leaf tip. And you can kind of see what that looks like over here on the right hand side of the screen. But as you might expect, where we've got phosphorus or got our starter fertilizer, you do see a bigger sort of expansion of these plants at 2, 4, and 6 weeks after transplanting. So again, overall, pretty positive response when you look at just visual growth. Now, this is to me where the rubber meets the road. What does this bring to the table in terms of cured leaf? And our answer is still nothing. And again, I was not super surprised. I was actually really glad to see this, because it just means that either we're doing something right, or the folks that came before us are doing something right, because we've got the same results with different varieties, different growing conditions, different products, and we're still arriving at the conclusion that this is not necessarily a value-added product or a value-added program from a yield and quality perspective, but there may be some hidden things about just getting a crop established a little sooner, letting it kind of get up and get going, that may be more valuable than anything. So if we look at all this aggregate data, we've got a clear positive response to starter fertilizer. We again did generally see some visual differences within each measurement interval, and then just the nutritional difference at 2 weeks after transplanting. We did not see any injury. Again, if you're going to see injury, you're going to see reduced plant growth and plant stand. That was not there, and certainly didn't have any impact to yield and quality. Now, this to me is where it gets a little more interesting, and there's a lot more going on here. So this is where I take and break out all 8 of those growing environments, and I start to look at again, location or year, location, and I've got our grams per plant at the 2 week interval, without starter and with starter, and then I've overlaid the average air temperature and soil temperature and soil moisture for that first 14 days after transplanting, and then the cumulative rainfall that occurred over that first 14 days. So we've got 8 different data points on here that we're comparing, and only the very bottom, 2024 Rocky Mount, did we see a significant increase in plant biomass at 2 weeks after transplanting, where we included the starter fertilizer. So we're starting to drill down and try to uncover what's pushing some of this change in the bigger data set. And if you look at this data, I'm not going to get into all the dirty details, but for me, I thought, okay, we've got a difference there at Rocky Mount 2024. There must have been something environmentally unique about that particular 14 days. And when you look at it, that environment wasn't the coolest, wasn't the hottest, wasn't the wettest, wasn't the driest. It was pretty much middle of the road. So there'll be something else I'll come to in that. But again, the interesting thing for me is you look at all of these numbers without starter and with starter. They may not be statistically significant, but we never saw a negative impact from the starter fertilizer. We usually see more biomass, and I think that's what's feeding into our larger data set showing some differences. We go back to the 4 weeks after transplanting data set. Same setup, but this time we see Rocky Mount 2023 and Rocky Mount 2024. those plants that had the starter fertilizer were bigger in terms of a biomass standpoint compared to where we didn't have the starter fertilizer. And it's largely the same story at 6 weeks after transplanting, except we've added one more field site here where we do see about a double, 2x increase in plant biomass at Rocky Mountain 2021. And again, as I kind of looked at this data, I kept going back to the environmental conditions. That's usually our trigger for where we see the biggest benefit from these treatments. And doggone if that didn't kind of blow up in my face. You know, again, these Rocky Mountain locations were not the coolest, not the hottest, not the wettest, not the driest. So what's going on? Well, that particular field site is the only one where a significant amount of our fertilizer was broadcast applied pre-planting. And even down here in 2023 and 2024, they were broadcast applying 6,6,18 ahead of planting. And then up there in the 2021, it was broadcast apply some K-Mag and some triple superphosphate and side dress with UAN. And there's not many folks I know that are taking that approach to putting all their eggs in one basket up front like that. So this is a pretty unique situation, but it just shows you how inefficient some of those pre-plant broadcast applications can be under certain conditions and certain situations. So it's difficult for us to, with this data set, correlate our climatic factors to our growth responses. We're going to keep doing this and see what comes about, but I'm not getting my hopes up. But I thought it was interesting that there was, in 18 out of 24 measurement intervals, at least a positive numerical increase in whatever the variable was, where we put a starter fertilizer in. And again, I think that's why we're seeing those significant differences play out when we look at some of the larger data set. So additional thoughts, again, I kind of expressed that about some of the pre-plant applications. And I would say that anybody, maybe if you are broadcast applying an NPK fertilizer ahead of time, and again, I don't see that as a common practice, there probably is good value in putting a starter fertilizer in because you're gaining some efficiency by putting at least something right in the root ball. And again, it's going to be kind of hard for me to speculate on how other starter products may perform under these conditions, but we have seen some issues, particularly when it gets hot and dry, about putting starter fertilizer out. And at least last year, I think back to April of 2024, we set, I think, our first test plots on like April 10th or 13th or something, and it was pushing, I think, low 80s that day. And then I know that by the time the end of April came, a lot of y'all stopped planting because it was so dry. And we finally picked up some rain in May to alleviate that. And then we had a whole different set of issues to deal with trying to find some dry spots. So as we got to late April, I actually sent a note to our extension agents that said, look, it's hot and dry, no rain in the forecast. We ain't had rain in a month. Think about your communications and conversations with growers. They need to minimize what's going into the setter water because we do have some adverse conditions, and any little thing, our wiggle room for error, our margin of error is much smaller than it would be if we had better conditions. And usually because of the lacking impact on improving and enhancing yield and quality with a starter fertilizer, that's usually the first thing I tell growers to take out. So again, this is an as needed, sort of if needed scenario. Okay, so I'll stop there. I've kind of summarized some of that, acknowledge funding and the work and our collaborators, and I guess I might have enough time for a question or two. I got to get back to campus for some other work, so I'm going to have to leave a little bit early, unfortunately, but I appreciate being here. But if there is time for a question or so, I'll be happy to take one if you've got it. There's a lot to dump on y'all. Yep, Mitch?
In your data analysis, did you see any positive trend toward days to flower?
So that's a good question, and Mitch asked about days to flower. And so did we see a positive trend that would indicate we could get to 50%, button or full flower earlier with a starter fertilizer? So we were not able to look at that. That's been an objective we wanted to look at, and we've just not really been able to do that. Now that said, that was a top priority for us, and we were able to get some data from some county agents that had some on-farm trials that did show a benefit to that. So we do know that in terms of uniformity and the plants just growing a little faster, you might shave off a week or so. And again, I think there's the bigger benefit there may not necessarily be, can I get to flowering a week faster? I think the benefit is, can I have more uniform uniformity in days to flowering, so that I'm not having to struggle with stopping and starting, a high boy whenever we're making that first contact application and really having a guessing game for what should get contact and what shouldn't. And that was a big struggle for us last year, as dry as it was. But yeah, we know that there's likely to be some benefit to that. Good question. Anything else? Okay. Well, thank y'all. Good luck this season. Hank, thanks for having me out today.